push this one on the tubing. It can be quite tough. There's a table of depth and resistance. We have 3 standard resistances. And basically what you do is press it down. Now, there was a question about what is the depth of the sampling. There's no doubt now we're at the bottom. So you can, from here, depending on the well stream, where do you want to sample? Press it up 50 centimeters, and then you have to fix it in the well. It's you cut the tubing at the right size, you close the well, and you come back in 2 weeks, or 3 weeks. And now we play that these 3 weeks were just gone. You're going to take it off. Perhaps you can help me with the...
At this time you mark
the coffin.
Where the water is.
In the tubing you would see a level here where the water is coming. This is your control volume. So this is just for quality control. You mark it. It's in centimeters. You put it in your protocol. This is a control volume. Then you remove cartridge.
Ja, inderdaad.
Take it out.
It's only benzene, it's no problem.
Yeah. Protection cups on, and then to the line. So that's a short.
You can send it by an envelope, like a belly envelope. You can send it to the.
You have another tubing put on here, which is extending to the surface. But this system is perfectly suitable for 2-inch wells, and the principle is just the same. But it's not very practical to press a tubing like that. Systems like this you can also hang down in a river. You can also put it over there, or if you have a container where you have processed water. Every place where there is some depth, you can just install it. The principles are the same. This is practical up to 20-30 meters on the surface, and then if you go deeper than that, we have a third system. Which again looks like this. It's very similar to the other GWS flex, but we have a very small tubing. The protection cap here is the same. A small tubing which makes it more easy to handle. If you want to go to 100 meters of tubing like that, it has a lot of... it's not easy. It's very easy with this. So what we do, we have some of these weights. We pull it over, stainless steel weights. You attach it on the tubing, and you just sink it to the well. And it's amazing that even at 70 meters, you can feel it exactly dropping at the bottom.
Why didn't you use this one in this?
Because the volume, that's because the volume would be too small. If you see here, if there is the water would extend, for example, 1 meter or 1.5, you have 3, 4, 500 milliliters, which is fine for a volume. If it's 1 meter of in this tubing, it's too small of a volume. So if you go 70 meters under, there's place enough. There's no problem if the water in the tubing goes 10 meters up, and you would still have the right volume. So remember, this is volume-based sampling. It's not time-based. It is a volume of water pushed through. That's very important to realize. And that's why it's also important to have the control volume in your tubing. But actually you can also see it in the cartridge. Before you send it to the lab, you would see if the system has worked.
So you need to measure the control volume. You need to put it in a bottle and weigh it afterwards.
You can bring a cylinder glass, and it's a control volume, because the laboratory will also give you a volume, which is determined by the trace salt. So you have 2 points of as a control, quality control.
How sensitive is the filter for iron oxide? Because with the normal filters for metals, if it's really iron, the water
That's a good question. If there is very high sediment load, the sampling rates may be affected. But you have to realize this is a very slow sampling. Perhaps only 10 milliliters per day, or 20 milliliters per day. And that means that there is a very small pressure gradient over the filter. If you want to do this sampling in 1 minute or 20 minutes, it would be clogged 100% sure. But because it's taking place over weeks, the flow rate is so small that there would still be flow through.
Because here in the tube you have 1.5 meter of water. Normally this would take several months before that is filled. Or
no, we can also, I can give you cartridges and it would fill in about 10 minutes. If that's not what you want. So we have the hydraulic resistance that allows to take to
that one was now left out of the system.
Sorry?
It was left out of the system. You just demonstrated first.
Which was the
Resistance.
I'm sorry, yeah. Just one last thing. If you go deeper, and we have done this several times, we use very small capillaries. And do they get clogged? No, usually they don't. But if you look at this, you cannot see the internal. I think it's this one is 25 micron. But because if you go 70 meters under the water, there's 7 bar of pressure. And the graphs I showed you with the yellow dots and the blue lines, it was done with a system like this. And we were able to keep a sampling rate of a few milliliters per day over a 3 month period. Without getting clogged. Yeah.
But there is no agitation, huh?
I would assume that iron completely blocked, but it doesn't. I'm convinced.
There's a lot of filtering on the way.